All right, so today we're going to do systems of equations, wordy problems on page 40. This is the example of what your paper should look like. All right, so the purpose of what we're doing today is that it's not a word problem exactly. When you take your end of course test, when you take your unit test, there are problems with a lot of words where they're asking you things. So they're not asking you to come up with the equation. You see, they've given you the system of equation. It's asking you things like, is this person going to get the right answer? What did this person do to create this new system? All right, so example 1 says that Jack and Rose are arguing about who is right and wrong on a homework problem. The problem is pictured below. So this was the original problem on their homework. Part A, Rose has rewritten the system this way. So this is what Rose says is going to work. And she insists that this new system of equations will result in the same solution as the original. Jack is not sure that Rose is correct. Will Rose get the same answer as the original system? Explain how this is possible or not possible. So, did this question ask you to solve anything? No, it hasn't even asked you to do any math. It's asking you, if Rose started with this problem and she created this, is she going to get the right answer? Now, let's look at what Rose must have done. If you started out with 5x and then Rose ended up with 15x, what did she multiply by?
3.
By 3. Okay, so we've decided she must have multiplied by 3. Was she only supposed to multiply the first one by 3? She's got to multiply what? Everything. Let's check her math. So what's 3 times 2y going to give Rose? And that's what she wrote down. So what's 3 times 25 going to give her? So did she do okay on this top one? Yeah, that's going to work so far. Let's look what she did to the second equation. So you've got negative 5x, and she multiplied by something to turn it into 10x. What did she multiply by? A negative 2. Now, let's check and see if she did the right thing. Negative 5x times negative 2 would be positive 10x, so she's good there. What's 3y times negative 2?
-6y.
So she's good there. And what's negative 25 times negative 2? 50. So, did she successfully create an equivalent system? Yes. So, if she created a system that's equivalent and is going to work, is she going to get the right answer? Yeah, it's exactly what you did yesterday. You had to figure out how to make a system where variables are going to disappear, and that's what Rose did. So, the question was, will she get the same answer? You're going to say, Rose will get the same answer. Now, it's not enough to just say that she will get the same answer. We're going to say why. Because you're going to prove your point. What is the evidence and what did Rose do? The facts that tell you why she's going to get the right answer. Because what did she do to the top equation? She multiplied by 3. What did she do to the bottom equation? And that created what we would call an equivalent system. So, because she created an equivalent system of equations by multiplying the top equation by 3 and the bottom equation by negative 2. All right, so in the next part is part B. And it says, what is the solution to the problem that Jack and Rose are working on? So if you need to find the solution, what are you going to do? You're going to work it out. Now, look at the original problem. Did Rose actually have to multiply by anything to create opposites? No. What could you have done? Just did the problem. So I'm going to just write down what the original was, because what is already my opposites? the 5 and the negative 5x. They're already opposites. So here's what I want you to do. I want you to work this problem out. Now, you, of course, could use Rose's system if you wanted to.
Can you scoot up just
Right there.
Yes.
But if you want to use this one, that's what I would do because I feel like it's going to be a little bit easier, okay? So you work that one out and let's see what you get. All right, so we should have gotten the answer 5, 0. So as in like parentheses 5, comma 0. Why do we list the 5 first? It's the x, good. All right, so now here's the work that you should have done. Because the x's were already exact opposites, we can just add these together. So 5x minus 5x goes away. And 2 minus 3 is a negative 1y equals 25 minus 25 is 0. Now, you would technically divide by negative 1, but 0 divided by anything really is 0. Now, this is where we get our y coordinate and our ordered pair. But the problem that we're having that I'm noticing this week is you get y, it's plugging it back in. What does 0 equal? Y. There you go. 0 equals 0. You're right. 0 equals y. That means this can be plugged in instead of y. So you can plug into the top equation or the bottom. It really does not matter. Which one would you like to choose? Top. I would have chosen the top as well. Why do you think Ms. Slusher would choose the top? Less negatives. Not because it's any harder or any easier if one is more right than the other. Simply because I, honest to goodness, just don't want to deal with the negatives. Now, here's what's happening. This was the equation. What do I now know? That y equals 0. So I'm going to erase y and replace it with 0. Now, 2 times 0 is 0. So what we've really got is 5x equals 25. This is 5 times x. What is the inverse of times 5? Divide by 5. All right? So then our x equaled 5. Now, if you left your answer like this, I would be forced to mark you wrong. Because this is a system of equations. And what is the solution to a system of equations? It's a x and y because it represents the point where they intersect and cross. So I would write my x first, then my y. If you write it like that, I'm going to have to take points off and mark it wrong. Why? You didn't put parentheses. It's not an ordered pair of point until you put those parentheses. Okay? All right. Let's look at my next problem. Now, the next problem is actually, example 2 involves 4 little parts. I didn't name it 4, but it all goes together. All right, so example 2 says, Ms. Slusher told her students to solve the following system of equations. Right there. That's the original system. 3 students, Huey, Dewey, and Louie.
Wow.
Do y'all know who that is? Woo! I love that show. All right, so 3 students, Huey, Dewey, and Louie, rewrote the system in a different way. Determine how each student created his new system and determine if the new system will result in the correct solution. So what you're trying to do is you're figuring out what did Huey do to make his new system, what did Dewey do to make his new system, and what did Louie do to make his new system. All right, so let's look at Huey first because he's the first one I see. He went from having a negative 3x to having a negative 9. So what do you do to negative 3x to become negative 9? Times it by 3. All right, so I'm going to write myself a note. He multiplied the original by 3. All right, so let's make sure that he did that correctly. All right, so what would 3 times negative 3x be? Negative 9, you're right. Negative 9x, so he's good there. What's 3 times this y going to be?
3y.
So he wrote down the right thing. And what's 1 times 3 going to be?
3.
So far, Huey's first equation is correct. So we checked that out, made sure everything was all good. Did he change anything about the bottom?
No.
Why didn't he have to change the bottom equation?
He changed the top.
He changed the top and then created what kind of opposites? Which ones are opposites, x's or y's? His y's are opposites, so they're going to go away and you'll solve for x. Now, did it tell me I have to solve this? Mm-mm. It just says, this is why I call these wordy problems. There's a lot of words telling you what to do, and you respond with a lot of words, all right? So you were said, determine how each student created his new system. You did that. He multiplied the original top equation by 3, and determine if the new system will result in a correct solution. Did he correctly get opposites like he was supposed to? So if he did this part right, what's that mean about all the rest of the work? He should get it right. He should be able to get a correct solution. Now, we're going to make sure we're using complete sentences, because when it comes test time or end of course test time, you have to write in complete sentences. You want to prove that you know what you're talking about. So we're going to say, now Huey will get a correct solution, but what did Huey do? What did he do to create his? Very good. He multiplied the original top equation by 3, which will result in a correct solution. Now, if this was a test problem, I'm looking for you to tell me 2 things. I'm looking for you to tell me that Huey is going to get a correct answer. But most importantly, I'm looking for you to tell me he's going to get a correct answer because he multiplied the top equation by 3. So it's because, I mean, let's be honest. You could just 50-50 guess. He's either right or he's wrong. You know that. Now, if it was a multiple choice question and I really wasn't sure, I'd take a guess. Either he's right or he's wrong. But this isn't a multiple choice. These are always going to be where you explain yourself. Okay, so get caught up right in that. All right, so now we figured out that Huey was right. You've got to do the same thing for Dewey and Louie. All right, so you're going to look at Dewey. Dewey took this original system and he says, this is going to work. Okay, so let's figure out what he did. I like to just look at the first x. The original had negative 3x. What did he multiply by to get negative 12?
6.
Nope.
Oh.
What's 12 divided by 3? 4. It's all right. It's all right. You were looking at the bottom. All right. So for the top, he had to multiply the original by 4. All right. So then let's see if he did that right, because he has to not just multiply the first term. He has to multiply every term. So what is y times 4? 4y. That's what he wrote. So he's all good there. What is 1 times 4? But what did he write? So how did Dewey mess up?
He didn't do it right.
What did he not do right? He didn't distribute to the constant term, the number. All right. Let's see what he did to the bottom equation. So we had 2x times what gives you 12x? There's your 6. All right. So he had to multiply the original by 6. Now let's make sure he did that correctly, because we already saw he had a mistake there. What is 2x times 6? 12x. What is negative 3y times 6?
Negative 18.
So far he's good. What is negative 3 times 6?
Negative 3 times 6.
Negative 12. Negative 18.
Negative 18. So did he do that right?
No.
So Dewey obviously has a certain problem. What is his issue? Because he did it twice. Not distributing to the constant. So since he didn't distribute to the constant, is he going to get the right answer? Okay, so let's tell what he did do right. What did he do right?
Distribute everything but the other one.
He multiplied by the right number on the top and the bottom. So let's give Dewey credit. So we're going to say that Dewey multiplied the top equation by 4 and the bottom equation by 6. So that was good, but he messed up. Where did he mess up?
On the distributed.
On the constants. Very good. Now, you know that when you write, you're not supposed to start a sentence with but. What's a fancier transition word than but? However. So, let's throw in those fancy transition words. However, the system will not get a correct answer. And here is where, well, I should say the word solution, because that's the proper word. Solution, because Dewey did not multiply to the constants. So we're going to explain what he did do right and also explain that he's not going to get the right answer because there's some things that he did not do right. So you need to make sure that you write down that entire explanation. All right, so now we got Louis. Let me open this up though because we got to be able to see the original. All right, so Louis had the same instructions. It was to make an equivalent systems of equations. So start by looking at the top equation. What did Louis do to the original negative 3x to get a negative 6x? Okay, so I'm going to make myself a note because I don't know about y'all, but I'm not good at remembering what I was supposed to be figuring out. Multiply the original by 2. Now, let's make sure he did that correctly because we saw the last guy, he didn't do it correctly. All right, what is negative 3x times 2?
Negative 6x.
So far, Louis is good. What is y times 2?
2y.
And that's what he wrote. And what is 1 times 2?
2.
So far, Louis is good on the top equation. Okay, so multiplying by 2 was the correct thing to do. All right, look at the bottom equation. So you started out with 2x, and Louis somehow managed to get a positive 6x. What did he do?
Multiplied it by 3.
All right, so I'm going to make us a note. Multiplied the original by 3. Now, we got to check and make sure he did it right because one mistake means the whole solution would be wrong, wouldn't be the right thing. So 2x times 3 is 6x. Okay, so he's good there. What's negative 3y times 3?
Negative 9y.
So far he's all right. And then negative 3 times 3?
Is negative 9.
So, did he correctly create an equivalent systems of equations?
Yes.
Yes.
So we'll get the correct
So he will get the correct solution. So, what did he do? Like, how did he do this?
He multiplied the top equation by 2
and the bottom by 3.
There you go. What you just told me is what you would write for your answer. So, Louis will get the correct answer or solution because now y'all know that when you're writing in English, you know, like in your English class, your lit class, you're not supposed to abbreviate, but we're in math, so we're going to abbreviate for right now. Okay, because now tell why he was right. He multiplied the top equation by 2 and the bottom equation by 3. Okay, so y'all get that written down, okay? All right, so now it's going to be your turn. You are going to determine the solution to the original system of equations. Now, if you go back to the original, is this ready for you just to go ahead and add them?
No.
Why not?
Because you don't have an x and a y symbol.
Very good. You don't have either both x's or both y's being exact opposites. They're not going to cancel. Now, you've already got two systems that are perfect thanks to Huey and Louie. You can use either one of them. Whose can you not use? You can't use Dewey because Dewey did not do this right. Dewey did wrong. All right, so you can choose either one. What answer are you going to get for both of them? The right one, that's right. So it doesn't matter. So what I want you to do now is I want you to choose either Huey's equation or system of equations or Louie's, and I want you to work it out right here, and let's see what answer you get. Okay? Yep, either one. Either one. Yes, ma'am. Yes, ma'am. All right, so now I'm going to write down Louie's, and the only reason I'm writing down Louie's is because it's right here. So I'm going to use Louie. All right? So I want you to solve it, and I want you to see what you get. All right, so Louie's system of equations, we determined he had already done the right thing. So it was okay if you chose that, and you should be ready to add. So negative 6x and positive 6x go away, and you get negative 7y equals negative 7. How do you undo times negative 7? Very good. We're going to divide by negative 7. So y equals 1. Now, that is my y value. You need to plug back into an original. Now, where am I going to find the originals? Way up here. But you could actually plug into either one of these as well, because all you did was make them a little bit bigger. So, look at my originals. Which one do you think Miss Lusher would choose? Does it matter? No, it really doesn't matter. So, my friend told me the top. So, negative 3x plus y, which is 1, equals 1. So, I'm going to solve for x. How do I get rid of plus 1? Yep, that's right. Subtract 1 from both sides. Negative 3x equals 0. I got scared for a second because I didn't realize that was going to cancel out. So this cancels out and gives me 0. I divide by negative 3, and x equals 0. Now,
Did you have to plug it in?
you didn't. You could have plugged it into either one of these, because all you really did was you multiplied that one by the original of this by 2 and this by 3. So you just made it 2 times as big or 3 times as big. It's all equal equations. Now, if you leave your answer like that, I'm going to be forced to mark you wrong. Why?
You gotta do the parentheses.
All right, got to have the parentheses.
And then X and Y.
X comes first, then 1. We'll get that in just a second. All right, now, this is a huge question that you need to understand. This is going to be the basis of everything you understand. Your solution to every one of these, to the system of equations, what does that mean?
X equals 0 and Y equals 1.
Yep, what does it represent? Where the two lines will intersect. That means that this point 0, 1 is on the top equation when you graph it and the bottom. And so specifically, the solution is the point where the two lines intersect. Okay?